Ladies and gentlemen, welcome to today's second session. Please give them a warm welcome for our next speakers, Stefano and Duilio.
Microphone? Testing. Perfect. Thank you to everyone to be in this session. I think you have a lot of people here. This is the session about the giant. So the goal for this session is to talk about some of the biggest customers, at least in Business Center Online today. And we want to show you some tips and tricks on techniques that we have used to handle such type of customers that, as you can imagine, are quite different compared to small customers. Together with me, there are the ducks and
Duilio.
Of course. So let's start.
With just a little bit of fun. So this is X-rated. And just to emphasize the bad habits, we just pick it up. Just one single quote that you're all so lucky that I do not own a dragon. Otherwise, you know what will happen if you apply bad practices that I can invoke the typical Dracaris. So everyone you see this slide, you can even use your lighter or say Dracaris or stay silent, whatever you like.
Every time it appears, it's something that you should never do.
Exactly. And remember, you're lucky that I don't own a dragon. Okay, so large customers. First, the definition, what it is a large customer. So what you have in mind as a first thing as a large customer. What you might think it is a large customer. Maybe it is the database size. So the first things, I believe everyone has asked, how it is the database size, like saying, okay, this is really large, but okay, you might have in the online version something that it is 1 terabyte, but you might have just 2 transactions per day because people are just accessing and looking at the data. So this one, it is green grass. It is not so complex to achieve. So database size, it is just another biases. The second thing is that you ask, look at this audience. You ask for a large customer, you think that it is the number of users. Number of users, it is just another biased estimation of something that it is different. So I can say I have 50 users, 1,000 users. What they're doing, they're opening the contact card or customer card. Green grass. This might seem a large customer, but this one does not give any harm, so to speak, to the people that have to implement, to the consultant or to the developers. So it is better if you know in advance, but it is hard to know in advance unless you're coming from earlier NEV version or from GP or some SQL Server databases from some of the competitors. The transactions volume and the types, because this one, it is shaping the locking scenario that you might have upfront, or the things that you are actually doing if you're doing this reactively, because you have already uplifted to the cloud one of these big elephants. Transaction volume and type, the most important, it is another one, it is the concurrency. When you know transaction volume and type and then concurrency, you have something that it is far better than the users, because let's say concurrency. I have a customer with 100 users, but they have rota. So 25, 25, 25, it is a 24/7, and you might see that concurrently, maximum, they are 25. We are in Italian, typically they are 23. I don't know the other two, what are they doing? But anyway, instead of the database size, that it is static, photographic, okay, this is 1 terabyte, but yes, I have this one since 1976. Okay, good, now I understand why. Database growth, it is better, so you just have to measure this. Month by month, year by year. You have to look at the capacity and then understand when it is time to put more money and buy or another production or buy much more spaces that you have inside.
Italian doesn't trash nothing, so
yeah,
database is growing a lot.
Exactly. Another one, it is the complexity that you have. So all of this plus the complexity. You might have some special ISVs that are going inside, plus you just have a full world of integration with the outside world. The power something that you might put inside. And this one, I call it the silent enemy, because you don't see it. But the web user perceive it if you have 300, 400, 1,000 calls per minute behind your... you got me what I mean. The last one, it is special requirements. They might have 24/7, very, very restrictive 24/7. And then you know that Microsoft applies application hotfix and platform hotfix, or you have to go into the next update. Luckily, the flexible update is making this 24/7 much more much more feasible to go into the cloud. And in my life, I've never found a real 24/7 that never ever applied the patch on SQL Server on Windows, or so there might be a Windows in order to apply this kind of patches. So just to define the large customer are the one with high transaction volume and type, with high concurrency and/or high concurrency and/or high database growth, high complexity, and maybe they have special needs. So if you have this kind of elephants, most probably you're working even Saturday and Sunday if you do not take your right precaution, okay? And you're lucky that I don't own a dragon, of course. Okay, so look at this one. This is one of our customer that they have it. If you look at the numbers, it is a real customer. You might think this one, it is a trouble. How can you uplift this one, or you've blown your mind? Well, you know, this one probably open one support request, and it is about the job queue, honestly, every 2 months or 3 months. Everything, it is going really, really, really good. You know why? Because it has quite a lot of isolation. It has 2 production, 47 companies, mostly 500 users, and then if you do the mainly financials, if you do the math, then this is 10, 12 users all in the financial side. So this one, it is really a large customer in the cloud with some integrations, but this one, it is really green grass.
Numbers is big, but this is not a big customer for the SaaS.
Exactly. So right now, you have to tackle the real problem, that it is high volume of transaction types and with high concurrency. So how you tackle this? So the first things, it is, you have to know your enemy, right? If you don't know it, you have to find out the right tools to know it. This is another customer, and this one, it is 500 licensed users, but concurrent, it is 100 users in, we are looking at the concurrent user, but then, of course, we have to look at the transactions that are made. This is actually the actual data. In 1 hour, you can isolate the number of users. Concurrent, on average, there are 100, the users that are perceiving the user interface. But behind the scene that is playing, you can see that there is the silent enemy. Okay, the silent enemy, that is this one, this baby. So they have quite a lot of integration. They have a B2C, they have a RAS management system, mass, and counting. Wherever you want, name it, they got it. So they have quite a lot of integrations. And this is something, and this is actually per minute, the number of web service calls that they have is plus they have the job queues and so on and so on. So handling this kind of customer, it is quite not so simple, but luckily, in order to know what it is running behind the scene, you just have to implement really a solid telemetry practice to analyze exactly what it is the concurrency in an exact spot of time or trends in 1 month, in 2 months, in 3 months, and so on and so forth. So I want to show you just an extract of the Azure Data Explorer dashboard that we are using typically in order to tackle, our customer performance problem, and just related on this, you can see it.
Should we switch? Okay.
Switch it. Perfect. On. Okay. So this is Azure Data Explorer. Your environment is emitting telemetry, and then from this telemetry you can analyze it. Microsoft goes with this Power BI, but it is not so just in time. What you are seeing, it is actually what it is happening right now. It is the 13th of June. It is live. It is connected to
this is a live customer, so we are
to
not,
a live customer, and you know that the telemetry does not contain
real live data.
Yes, live data does not contain any PII, any private information identifier. So I'm just working with just 3 of the signals that are 200 and counting. Okay, just with these 3 signals, what you can squeeze out in know from what is happening behind the scene in your customer. So what I did here, I've just, let me pick it up, just higher volume of days. So in the 90 days, you have the number of long-running queries and the duration of the long-running queries. Okay, the number of long-running queries, it is one that is higher than 750 milliseconds. This has been established by Microsoft. I don't know why. Probably they flipped the coin, and 750 gets out. So you might, I just want to see how I analyze this kind of stuff. So in 90 days, there might be a trend. Let's not consider the spike. The spike, it is obvious right now. You can see the part here. What happened? There was something in this environment, and it was low. But why it was low, this environment? First things that I want to see, it is what this is depending from. It is depending from the web services, from the background session. Okay, I'll give you just, again, you can filter this one, then you can see only the background session in 90 days. So everything that it is flown inside within this dashboard, it is filtered by background session. And you can see, okay, there was a problem in the background session. Then you can filter, these things are emitted, right? Are emitted, then you got the timestamp, then you can filter. Was this really a problem because they were working during the day or not during the day? As you can see, the problem was during the night, but during the night, sometimes there was a flip in the background session. This one goes and flowed into the working hours. And then people start going down, some lock timeout appeared, etc. And then we fix it. Okay, we took some time to fix this, but actually we fixed it. And as you can see, this is really green grass. Let me put this back. You can do quite a lot of stuff with just one single signal. Okay, let me put this on 14 days. Another thing that I want to show you, it is the average duration of a long-running SQL queries. Oh, let me put this back to everything.
Exactly.
Okay, now you can see the average duration of long-running SQL queries. So I'm taking all the long-running SQL queries, then I'm taking just the average, divided by client type. This might be useful if you, overall, if you have massive web service calls, etc. At some point, maybe they take 1 second, the day after it is 3 seconds. Why? On the average. And then you can see that everything is slowing down, then you can investigate. I just want you to show what this kind of things means. Let me pick it up maybe, again, 30 days. And I just want only to pick it up the web services. Okay? And surprise, you can see this erection of signals. The erection of signals, it is Sunday. Because on average, the web services are running quite fast. 1 second, 1.5 seconds on average, right? But on Sunday, you don't have this kind of B2C working so much. On Sunday, you just have other stuff that goes into the BI and into other kind of integration that are more longer than it was. So those are the data that you can squeeze out with just one single signal, that are the long-running SQL queries. And then, of course, you might have some seasonality. Seasonality means that what about the weekly cycle or the monthly cycle? So that's the weekly cycle that might tell you, okay, are we going good? Yes, well, it is decrementing the number of, on the left, the number of SQL Server, long-running SQL Server queries. This means two things. Or people have been fired, and then you have less people, less transactions. I don't think so, because they are growing and growing. The second one means that it is going faster for somewhat reason. For many reasons, it might go faster. And then this is the duration of the long-running SQL queries. Okay, let's go back to maybe other 14 days. And this one, it is very interesting. When you receive the long-running SQL query, you have the SQL query. Within the SQL query, you have the statement, if it is select, update, delete, create table, whatever SQL statement, plus you have your fields, plus you have your where, you have your read isolation stated. You can use a regex and then manipulate this one and see, okay, how many reads I have, how many select I have, how many create update I have in this period of time, and how many the others, you know, Nicole Kidman and other people. Okay, so one thing is that in 14 days, as you can see, they're reading quite a lot. So that is typical from an OLTP. They read 89.7% and then 10%. Sometimes it depends on, this is manufacturing, so they are also writing, but the problem is that they have also quite a lot of reading inside. You can also change this one and see, okay, let's pick it up the last 3 hours. I don't know how we will figure out, honestly. So right now we have 95.2 and 4.8 of write, but who is the one that is responsible to writing most? Yeah, you might think it is web client. No, the web client, they're reading quite a lot. They are not. It is other silent enemies, all this kind of automation. So again, I think it is the background client that it is performing some stuff. It is writing 87.2% of the time and reading 12.8 of the time, at least in the last 3 hours. Okay, so this is just one single statement, the things that you can squeeze out in the overall. Now let's go into dive into the analytics. Okay, so pick up your pillow and put your on the back, and then look at this one and don't fall asleep. Okay, so right now, just to give you that I'm not telling any kind of things. This is the last 3 hours of this day within this customer, and I have extracted actually every hour how many distinct of user telemetry do you have it, and as you can see, they are pretty much working because we are on more than 100 users actually are working on it. But as mentioned, I have to pray what I preach, right? Let's look at the sessions that you have it. Web client, typically you have 1 or 2, so it would be 200 sessions. But the one that is giving really an headache, it is the baby, it is the web services. 6,000 calls per hour, 9,000 calls per hour. They want data. So you just have to shield this kind of things with good code and with other stuff that me and this beautiful guy, we will show up during the day. Okay, so move on forward. In the last 3 hours, I can take all of this query. Okay, this query, it is the long-running query signal is geared up by the IL stack trace. That is the beautiful things. The people that are old like me remember the old client monitor, where you can correlate the CIL statement with the SQL statement. Within the telemetry, you can do pretty much the same, very similar stuff. So you have the stack trace, and then you have the SQL. So in the last 3 hours, I have summarized what it is happening and added the percentage. So 12.5% it is made by this guy here, this select that it is in the IL stack trace. I'm not opening it up, but you know the 12% in the last 3 hours coming from this kind of activity. And you have to concentrate on this kind of code to make this optimal. Maybe you have to refactor, or maybe simply just have to apply rules like read isolation, settled fields, and all of this kind of stuff. And just some fancy graph, the top 20 objects in the last 3 hours during the long-running SQL queries, and the one that do have a lock, okay? Those one are overall, and this one just the one that are actually locking. And in the last 3 hours, in here, you just have all the days of the long-running SQL queries. This is actually what it is happening behind the scene, ordered by timestamp, so this is the concurrency. If you can see this one, it is 11:15, and it is 11:18. There might be some delay in when you receive data. If I'm clicking refresh, most probably I have just an extra data. I have dissected this signal, and from this signal, you might know what it is, the duration, the type, how many flow fields they have, the join, if there are. In the past, it was useful when there was this table extension. And then if it is locking, not locking, I have colored in a different way. If you see one blue, this means that, this guy might be a problem. Well, it is just not a problem, 790.55 milliseconds. The object information, the stack trace, extension information, SQL statement, everything, plus the user and the session. So if you want, let's say, to see how it is the concurrency, this one is very big. It is hard to put your eyes on. But let's say that I want to see, to make a visual with user telemetry D. This is one colored by the user telemetry D, and those are the users that are working together in the same spot. I'm taking 3 hours, so it is quite a huge amount of data just to see. And this one, it is my little jewel. So in every 10 minutes, I pick it up, how many SQL statements have been emitted, and if they are select, or if they are update, delete, and insert. In this kind of cases, you just have your panorama of if it is locking, not locking, or if something might happen. This one, it is just the number, and this is the duration. You can just simply add this one in here, and then this one, it is the number of query in update or delete, and this other one, it is the duration. With Azure Data Explorer, you can even look up, I've not added this, right-click the taste, and then you can see which are the queries, like the typical flow field that we have in AL. Okay, you like it? Good.
Good.
Remember, I don't have a dragon. Okay, then you have the long-running query count per average day buckets. This one, it is just a pivot on every query, measured every day how this one it is changing. Let me filter out for this one, for 70351, because we made the changes. This one was really impacting with the count, and we made the changes on the 3rd of June at 5:55. I would have preferred 66, but it was not possible. Okay, let's make it 14 days. So this one will turn up, and then this one, it is a pivot. And within this pivot, it will report me the count. Yeah, might take just some few seconds. And this one will report me, okay, perfect. Will report me the count for every day, how many times every day it has been called. But the things that I am interested in, of course, I can export into Excel, because if I right-click and then say export to Excel, I have this into Excel and send it to people, to developers, to wherever it is. But the things that I want to show you is the average. So that is the average. On the 30 May, 4 seconds. And then when we did this change, we changed this. It was 4.7 the day before, that was Monday, from what I remember. On Tuesday, it was 4, because at 5:55 we changed it. So they started to come the one from 2 seconds, right? And now it is 2 seconds, 2 seconds. We just reduced it by 50% with these changes, the impact on this specific query. And you can measure this up quite easily. The settled fields, it is something quite good. The settled fields, in all of this query, I've picked it up, and with some regex, I have extracted the number of the fields that you have inside. And I've ordered by the number of columns selected. Do you need to add settled fields into this kind of scenario? Okay, just filter in here. I'm taking everything, and then put this like between 50,000, that is the PTA range, and then give it to the developers, okay? Okay, or send the Dragon, of course. You can see those are the number of columns selected, order, and then the count. But you can even sort this by count, and then see, okay, maybe this one needs a little bit more joy. Well, not, it is a DLC, so this one it is for the Power BI. But you got me what I mean. I can export this one into Excel and then send it to the developers. Then the developers, there is the stack trace, and there is the SQL statement. They go one by one, and they fix it. Then the day after, we can measure the performance, okay?
This gives you an idea of object that you should check, because there's around.
Yes. And this is just one signal. Okay. Just one signal. Okay. Then let's talk about just a little bit logs. Okay. Those are the logs on the left. Choose whatever you like in order to fix your house. Then let's see how it is logging in the last 3 hours. The things that we have. Most probably not that much from what I've seen already in the SQL. Those are all the table that has locked by duration in the last 3 hours. The GL entry, GL register, then some custom tables, so on and so forth. It might be benign or not. Then you have the top 50 SQL queries that all database logs. And this one are ordered by total cost. Total cost, it is the number and then the duration. You can take this one, and of course there is a stack trace, and then send it maybe after 2 weeks or 1 month. Okay, take the top 20, analyze the code, optimize, you know, the cycle of performance. Yep. And then behind the scene, you just have log by calcsum, log by empty, log by count. You know, I don't want to stress the fact that read isolation, most probably it is one of the biggest things that we were waiting in decades. And this one will tell you if there are calcsums with log, if there are is empty with log, and count with log. Typically, we start with a positive approach. We are Italians, we are positive. So we put a read isolation on it, right? Don't be pessimistic on the calcsum, etc. And this one will make it disappear deadlocks, or even sometimes just lock timeouts, depending on the transaction. Now we had the dreadlock. I just put something just to make a smile, because at this point, typically people are more or less sleeping. And then you can catch up the deadlock. Okay, this environment, I do have 100 people that are working, plus you just have the silent enemy behind the scene, and believe me, if you have 1 or 2 deadlocks, they don't call me. Typically, the deadlock are appearing in this time, are appearing in the Power Up, the sprint completed. They do have a warehouse, typically 42, if I'm not wrong, 42 handler devices. So they shoot, and when they shoot, then everything, it is sent over also for the printing. Sometimes they receive a deadlock, they shoot again, and it works, okay? So don't ask me to fix it, or I will charge for quite a lot. Okay, so this is the things, the SQL deadlock by table, we just have one. Let me make it just a little bit more than this. maybe 7 days. And then with the deadlock, you just have the order. So the percentage, what is the table? The item ledger entry, of course, because you always have to go to the find list, wait. But luckily, with the new approach that we have with the number of sequence, this one might not be so scary as it was in the past. So those are all the deadlocks in 7 days. Believe me, those are quite natural in this environment, plus some fancy heat map in order to have deadlock by sources and table, and AL method by table, in order to emphasize which are the ones that most probably need some joy. And then, of course, this one, it is good if someone is calling you, oh, what it is happening? Well, there have been deadlocks in the last 5 hours. Every 5-minute buckets, I'm catching up if there are some deadlocks. Okay, lock timeouts, we are lucky because we had some of these lock timeouts, but I think where they're coming from. So there have been lock timeouts in here. If you notice one growing and growing, this means that you're running MRP behind the scene, or you're running something that it is locking behind the scene, and you have gone to take a coffee, and everyone, it is lock. This one, it is also helping you in understand which are the processes and remove this person, remove the problem that you have it. So those are the SQL lock timeout in the percentage that we had in the last 6 hours. Yes, I know what they are doing. This is quite, for the volume that they are moving, it is quite physiological, so to speak. And then you have the lock timeout. You know, with the lock timeout, you just have the people that has received the timeout, but you do not have the one that is the long-running query. But and you have the snapshot, of course, of what was running behind the scene from a locking perspective. What I've created what was running. What is what was running? Let's say that we had this at 9:12. The what was running, it is taking a custom range. It's 9:12 to 9:30. It just want to show you what it is. If I'm clicking apply, it will take the timestamp and the duration. So you will have a start time and end time, and you will have everything that was running that has been signaled in here as long-running query or long-running application method. This long-running application method, they have, as you can see, those are the ones that were running, and then they were running since here. Most probably this happened because in one of these, you just have to analyze what was running, then narrow down where the problem is. And this concludes the simple, small part related on the telemetry. Within the telemetry, you can really go down to every single piece of what a big customer is doing. Yes, you can switch.
Okay. So now we start, after seeing a live customer and how it behaves on telemetry, we want to start explaining the optimization part. So this is the status, and now we started optimizing things in order to, first of all, avoid the deadlocks and lockings, and optimizing performances. The first piece of work is related to posting. Posting, I think that you know that in Business Central there are some code units that for posting are quite problematic. Usually the posting code units, if you analyze the macro blocks of the posting code unit, it takes a small part of the time for locking the current document momentarily in order to check the number of series and something like that. And then the long part of the time is spent on writing. So on writing on the ledger entry tables, the rest of ledger entry, something like that. And then it plays also a lock on the GL entry table. We use it as a semaphore in order to avoid, to guarantee the concurrency of the transaction. So in order to optimize the performance of a large customer, when you have concurrent transaction, you need to try to start optimizing, and also Microsoft has started to do that, the part where you spend a lot of the time. So this is the part that we need to put the focus on. And now we will see how we handle that. So, Duilio, if you want to...
Yep. So the things that we did actually, okay, let's have a look at BCPT, Business Central Performance Toolkit, and then try to pimp up sandboxes. So I'm working on a special sandbox that has a typical tier, more or less, of a production. So behind the scene, I have a business critical database that is just behind the scene. All the rest, it is like it is in the SaaS. So we run this BCPT, and we try with do experiment for quite a long time. So quite a long time means 6 hours, 8 hours continuously. Try this kind of sales post, and when we started, immediately we received, if you do this kind of sales post with 10 session, 12 session, or whatever it is, immediately you will receive this. We can save your changes right now, so you receive a lock timeout actually in the GL entry. This means that, that you have to wait your turn, and then after 30 seconds, you have to go and try it again. So there are quite a lot of this kind of session. This means that this concurrency will kill you, because your user will receive actually this error quite often if you have quite a lot of this user on the other side. Meanwhile, we were doing this, we were seeing also a slope going down, 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 and we were using a Cronus. Remember, Stefano, what happened?
Exactly. The first thing that we discovered, and with the tattoo on every developer in our company, is related to automatic cost adjusting. So automatic cost adjusting is a big problem on big customer and on high transaction customers. So this is something that you should remember, and you should usually disable. So automatic cost adjusting in the inventory setup should be set to false, and not always, because if you do that during posting, it takes locks and it creates a lot of slowness. So for biggest customers with high transaction customers, we absolutely disable this feature, everything, and we schedule the cost adjuster report, so this report, in order to be executed in the background and not in real time. During that in real time, you kill the performances of the application, the performance of posting. So this is something that in our video is Dracari. So you should absolutely avoid to do that in large customers.
Right. Okay. So one solution to concurrency is do not have the concurrency, like in the Fight Club. The same things. Don't talk about Fight Club. No concurrency. You serialize. So use background posting, or do something in the background in order to serialize and avoid to have this kind of locking. So the things that I did, actually, I've changed this. This execution using the normal sys post via job queue and queue sys solder, sys header. I just rerun everything. Everything was running, of course, and those have been the results that I had, because some people asked, what if I have 1 million of records, and those were actually the results that you have it. You might take this with the plus minus 10, 50% if you want to go into production. Otherwise, you just have to put the fingers on the posting routines. Those are actually the number. So the random change line between 1 to 5, this means average 2.5. And 1 to 10, this is the number of sales order posted per hour. This one will be recorded so that you can stop it and see what were the results if you just want to approximately size the average limit of that you would like to achieve within this kind of using enqueuing and the job queue. And the result is that when this one it is running, then you can see it is flipping up and then popping up quite a lot of this job queue. But let's make it just showing up how this one it is working in the real life with the BCPT. That not one there to show. Okay, I think you see. Yes. So this one is the BCPT project. BCPT comes with a Visual Studio Code IL extension that product group thrown away some times ago and never maintained it. So it is useful if you just want to create a simple prototype and start playing around. So this is one. It is just the standard. And then the only things that I've changed in the BCPT sales post, it is just one line in here. So instead of posting, I'm using background posting. Plus, I have just added some bit of spice in here. That is, I'm just randomizing, and then I'm just creating a random line. So it might be 1, it might be 20, it might be 15. So on average, it will go into the average of the maximum lines that you have. Plus, I'm sending a signal just to have fun. And with session.logMess, I'm sending also another signal to see what was the average number of lines, the first number of order, and then the last number of order, just to understand how these things it is evolving and to have just a little bit of fun. I would like to show you how this one it looks like. So this is actually Thor, that it is my powered sandbox. And if I'm going to BCPT suites, then I have two actually. The one for BC TechDays, how does it work, this one? You publish that object, that code unit, that is this one. And then within this code unit, then you define what it is your scenario. In this kind of cases, it will be for 3 minutes. And it will continue to generate and then to spawn up a job queue for 3 minutes and with 10 number of sessions. I can increase the number of sessions, but let's start with this 10. So let me start this one. So when this one it is started, the things that it does, it will start to log everything. And it will log also what will happen into telemetry and inside log tables. So if I'm refreshing here, you should be able to see that right now there are 2 sessions, 2 iterations that has been done. This is the total duration, and so on and so forth. If I'm going into the log entries, right? If I'm going into the log entries, I can see I've already pre-created my analysis view. This one was presented in another BC TechDays, and there was an export into Excel with the pivot. Now you just have analysis entry, and then you can see what is running behind the scene. So behind the scene, you can see that this one, it is now running. There are 8, and this is all the scenario that is running, and it is taking on average 634 milliseconds and 320.865. It is the average number of SQL statements. This one, the same things, you can even forget about it and you go into telemetry because the same things it is emitted into telemetry. Then I have yet another dashboard. Maybe this is the baby. And then if I'm refreshing this dashboard, there might be something inside it. Voila, the same things. Then you can see that right now I have 90 that has been in success and the average duration, the average SQL statement. This one, meanwhile, I'm switching between one and the other one. There are the 2 sessions that continuously munching, and then creating the job queue for within 3 minutes, and this is what I was mentioning. This is my custom signal, and at the moment, the average number of lines, it is 10.9, and the minimum sales order number, it is this one, and the last one, this is the maximum. If I'm refreshing in here, then this number is changed, 35, so on and so forth, and this is for 3 minutes. And this is what I've used to make my experiments. If you want to test scenario even more complex, you might add more code unit, more people, more concurrent session, and then you can try to have your load as much as similar as possible to your customer. This is very good for the on-premises, super good to be used for the premises. To the online, it is not open to production, but only to sandboxes. So it is sort of useless. It is good to spot out very easily the concurrency because the database tier, it is very low. But I'm just praying that at some point in time, we will have also a pre-production or a sandbox that do have the same tier in the database as a production so that this load test would be really, really good in order to be performed. Okay, so far so good. Let me go back. How's that? You like it? Okay, perfect, awesome. That's it for the first part. Let me go back to the BCPT. Okay, we go back to the BCPT, refresh. Let's see if we have ended up with the one. So let me stop this one. Then this one will cancel all the sessions. Okay, I'm closing this one just to be a little bit faster. And then I'm going into here again. And we can move on to the...
This?
Yes, to the next one.
No, this?
This? Yep.
Okay. So a large optimization that we have done in every large customer that we have is try to avoid every time that is not related to number series and every time that sometimes requires to use auto-increment or worst cases like, for example, handling increment of numeration in your insert trigger of tables, something like that. So we start using number sequence. Why number sequence? Because number sequence are handle in a different way in the backend, so in Azure SQL or in SQL Server. Number sequences are totally relies on what are called SQL number sequence. And these are not handled at the table level. So these are not required an access to a physical table in SQL, but are absolutely performant in terms of locking and in terms of reliability. So Business Central has introduced number sequence from, I don't remember the number of the release, some releases ago.
15 or 16.
Probably.
BC 15
and
or
sometimes
16.
These are totally forgotten from the developers. But with number sequence, you can, first of all, create a number sequence object with the number sequence keyword. And you can, this can be per company or not. You can, for example, like in the first example, detach a number sequence starting from zero, incremented by 1. And this is absolutely better than going to a number series, obviously, but also better than using auto-increment or using the on-insert trigger to handle the increment by 1. You can also, because we have no SQL access, and you can also, not table access, and you can also use the next operator to obtain the next number, but you can also reserve a range. And when you need to post a set of records, for example, register a set of records in a table, in a large table, instead of, and you need a numerator for these records, instead of going into the table or number series or into the table for retrieving a numerator, for example, with identity or something like that, it's much better to do that because, like in this example, here we are reserving 10,000 number series. With the standard number series, it takes about 2 seconds. But if you do the same with the number sequence, it takes 40 milliseconds, so extremely faster. Obviously, where's the drawback? The drawback is that number sequence, if you reserve a range, it gives you the range that you can use for your records. But if you have an error, you have a gaps. But usually gaps are absolutely okay when you need to insert a record in a table. So usually you don't need to have gaps when you have fiscal document or something like that, but not when you need to post in the warehouse or need to post in item ledger entry or something like that. So we have totally refactored that in order to use number sequence in our biggest customer.
Yes, and this is also what Microsoft did, and it is doing. So the number sequence, it is an object outside the table, so you just have to access it, take the number. It is like a ticketing system. So it is not bounded to any table.
Exactly.
And, but there is a cost of it, that it is the cost to pick up the ticket and then assign it. That is, the problem is the latency in this. If you are doing just quite a lot of this.
But it's much more, less costly than doing.
But if you know in advance how much of these numbers you needed, it is just one single statement and it will give you just the range. Start from here, start from that one, period. Okay. Now, yes. So what has been done by Microsoft in actually 2 waves. In version 25, it has been introduced these number sequences in the warehouse entries. So if you are in version 25, you can enable it, and we have enabled it, and it is working just fine. But in 26, it comes the Armageddon. The Armageddon means that right now, even item ledger entry and value entry can use the number sequence. This means that you are really doing something that in a decade, more than a decade, Microsoft didn't dare to do it before. So in all of our big customers that have moved and are moving into version 26 right now, we are enabling all of them. And
this should be a mandatory best practice.
Yeah, mandatory best practice if you have for all the customers, but overall if you have big customers. And this is just one single small pattern that you might find if you go into the warehouse entries, item ledger entries. You can see that when there is the insert records, the insert record, before of it, there is an assignment of a shift bucket number. That is a new field that has been added in order to reduce statistically the possibility to have a deadlock on specific shift. So in short, if you just have shift on table like item ledger entry, value entry, and so on and so forth, you move to the version 26, you want to enable this field, and then just also change your keys in order to add also this shift number, and more or less, I think 95% you're good to go with this new process. So let me show you this live, because I don't know if this one has been shown, but I just want to show you this, how this one it is working using BCPT. Right. Thank you. Okay, so I just have another BCPT in, I've called this inventory, another scenario, and within this scenario, I'm just executing this piece of code here, and this piece of code, it is just simply create an item journal and post an item journal. To create an item journal, just filter it for, in this Kronos databases, for an item that have inventory, and does not have reordering policy, otherwise it will block me in the assign one. So I just want this to flow, to show you how this is working with or without having this feature enabled or not. So this is just very, very, very simple stuff. So let me go back to yes, in here. And then how those are, have been this feature enabled? Yes, this feature has been already enabled. So I would like to show you how this is working, the feature management. This is the typical setup that we have on our customer. So we are enabled, of course, do not calculate the flow freeze, that Stefano will show this in a minute, plus all these other ones, right? Those ones are all enabled. So this means that right now my item ledger entry will use, and all the other ones will use the number sequences instead of the typical number series go and then take the last number, block it, take a lock on the last number, and so on and so forth. So let's make it to work. And this will run for just 1 minute. I'm just starting it. So this one, it is started. And then we will have 15 of these that we are continuously posting and posting and posting and posting. And of course, we can do always the same typical stuff that we do. We go into the log entries and see right now in the inventory posting, I just have this one that I've called higher concurrency. And then as you can see, there are already 8, and then all of them are in the success scenario. This one, it is working. As you can see, this one, it is slightly growing, see? 7, 8, 10 seconds, because behind the scene, they are taking just a little bit time, but they are not blocking each other, actually, right? The same things that you can see, of course, using telemetry. You have to be addicted. I just want to filter out with inventory, that it is the code that is sent in over, and I just want to see if there is something. Oh, there is one that has been errored. Maybe it is something with the paging or something on this flavor. I don't think it is related to the, personally to the concurrency. It might happen this one, in this kind of scenario, and then this one, it is flowing and flowing and flowing. And when 1 minute it is over, yeah, if I'm refreshing this one or I'm going back, yeah, then maybe 1 minute it is spent. I don't think that we will have an error on the locking routine. It might be something else within the higher concurrency. There should be one error. It might happen. And then that's the error. Exactly.
This is
the
what
record in the item
the
application already exists. There should be something behind the scene, but it is not actually the item ledger entry that it is blocked. Then you have to narrow down what it is. Okay. That is the thing. And right now it should be over, because 1 minute should be passed by. If I'm refreshing this, okay, it has been completed with just one error. Right now, let's do the experiment and then change this in the feature management. So we do in the feature management and we run the same, exactly the same things. Imagine that the error with the item application never happened. It is not the same error that you will see in just a few seconds. Let's disable this. So fall back to the normal routine. It might take just, depending on the number of entries that you have, it might take some time to adapt. I'm just typically changing to this one just to let you visualize how it is typically. You can see this scenario. This is the scenario with the Dracarys. That shouldn't be that way. Around that, right now that I've changed this one, within this one, I just need to log in and log out, because of otherwise the new session won't take this one. With the BCPT, it is just a little bit stingy. So normally the things that I'm doing, I'm just closing it and then opening just another session. Okay? Even though the session are spawned by this one. So I just want to be sure that right now it is not running using the number sequence, but the old way to do the stuff. Then I'm going here into the BCPT suites, and then going to the inventory. one thing of the BCPT is that you can compare one run to the other one. So if I'm adding this, the base version is the 16, the things that it did, it has changed the value in here exactly with the same one. So 54, it is the 16th, and this one, it is again the 16th. If, for example, if I change this to one with this 15, then the value will change with the previous run that I did it myself. So I just want this with the 16, so the next one will be the 17. And the 17 will make the difference between locking, between the two type of scenario with number of sequence and without number of sequence. So let me start this one. This is again higher concurrency. I should have called it lower concurrency, of course, but never mind because I have the version. I should have changed it to the tag. But right now, if I'm just refreshing, at a certain point you will see that there will be an error. And you will see the number 17 that will start just in a few moments popping up. Okay, let me go back to the in here and then see the log entries are just already flowing in. And then with this scenario higher concurrency, I have the 17 one that it is a scenario with success already. Yeah. And as you can see, it is already just pumping up with 8 seconds. This one
slowing.
Should go up until 30 seconds actually with this 15. And 30 seconds means lock timeout. So in lock timeout, it is the bad error. Okay. Let's see how this is moving.
So with the
on.
standard feature, the posting is slowing until lock timeout. So that's why.
If I'm refreshing right now, I have all the success in the scenario. There is the average duration. And sooner than later, we will receive this error, hopefully. This is true live stuff. So this one, it is still running. Oh, it has been completed. And let's see if there is some error in here. It should be. All success. Well, anyway, yeah, I would have expected the opposite, but if I run it again, yeah, see, it is quite close, 25, 26, 26, 26. If I run this again, this one will generate an error.
So that's the standard posting. So if standard posting is slowing down until usually you have an error when you have a lot of transactions, concurrent transactions.
Yes, I should have tried with 20 so that you can see. One thing that you want to notice, it is this, the previous one was slightly faster because you don't have to do this kind of access to take the ticket in the number of sequence. But the other one has much more concurrency than this one.
Exactly. Switch, okay.
Yeah.
The other big problem that you should start optimizing is when you have flow fields. So flow fields, usually a customer abuse of flow fields. So when we have heavy statistical table, so heavy table, and a lot of statistical field on top of this table, you should start optimizing that because this creates a problem. And in version 26, there's this feature called calculate only visible flow fields that by default is turned off, sorry. You should always turn it to enable it. Also, if Microsoft declare it as preview, but in our opinion, it's absolutely recommended, mandatory to turn that on. And flow fields also create slow locks and slowness also when page loads. So in this case, we have in many scenarios for that, we have totally refactored our solutions in order to change from flow fields to page background task because page background task plus read isolation and set flow fields, mandatory, in order to improve that. And just to very quickly show this in an environment, let me refresh this. Here I have, sorry, first of all, I need to check the feature management. And in feature management, here you have the settings. So this is as standard, this is disabled. What happens when it is disabled is happens that if I have a table like the following, not this environment, sorry, but this environment. If I have a table like the following, this is a table where I have my entity, and then on top of this entity, I want to calculate statistics on top of an heavy table. So in this, just to show you the code, this is my table, where I have in this environment about 3 million of records. So these are like the item ledger entry or something like that. And then I have this table, where, as you can see, I have a set of flow fields, a large set of flow fields that goes on my heavy table. What happens in Business Central as standard, if in this table, so the small table, I go to check statistic, and so loading the flow fields, it happens that I click on this, and this waits, just only for showing one flow field, because this is only the only flow fields that if you check my code, I have as visible. All the other flow fields in the page, this page, where is, not this page, sorry, statistic v1, okay, this page, all the other flow fields are visible false. So as standard, my page is slow, only because one flow fields is displayed, because Business Central as standard until today always calculates flow fields. Also, if you have that disabled. But if I turn this feature off, so I go this and I, sorry, turn this feature on, not off. Edit. I enable, come on. I enable. Why I cannot enable? No, it's this, sorry.
Yeah. Dracaris.
When you are here, it's very easy.
Dracaris.
Okay. Enable, I need to sign in and out. Let me do this. And what happens here is that now things changes. So this is why this should be enabled. So if I go back here, and I now I call this page immediately goes out. Also, if the underlying table has 30 flow fields, because it works without calculating the flow fields. Obviously, where's the problem? This. Because in my code, this is a calculated field with a formula, like this. This is the difference between two flow fields. So if the flow fields are not visible in the page, because these two are not visible, this field is not calculated if you do that like that. So this is the only drawback. If you want to do that, or the flow fields are visible, or you need to calculate. Another thing that I want to show you is that with this feature active, here I have a second page that shows me all the fields the flow fields automatically calculated. This statistical page usually takes a bit of time to be calculated, and you can also change, like in this page, like in this page, like you can see now are 0, and then after a bit of time are calculated. Why? Because this page uses page background task, and this is absolutely useful if you have pages that you want to be responsive, because the first page can take a lot of time in order to calculate the flow fields. With page background task, you can do something like in this page. So the main page can pass a parameter to a background task, so in my case a code unit, and then in the background task I'm calculating all the flow fields that I need, so all the calculation that I need. So that this page retrieves in these pages, the video 2 page, okay, this page calculates, and then the caller page retrieves the calculation from the code units that you can schedule as background. And then, in this case, I'm displaying the fields. So this is the difference is that only displaying flow fields, you need to wait to the calculation. If you use page background task, the page is responsive. So then this changes. So that's why we have used these techniques. Obviously, when you calculate page background task, how you should calculate the page background task as we explained before with this technique. So this should be a mandatory technique. So go into your table, set the read isolation in order to have no locks, and then filters. So doing that, read isolation is and set all fields if you need is mandatory in order to have a no locking calculations. Let's jump back to read because you are absolutely late. Another problem: high database grow. So one of the problems is that Business Central data is costly, and usually databases are growing a lot. So you should plan for a data retention strategy from the beginning, because if your table becomes too big and you discover that after 1 year or that your project is live, this is a big problem, because deleting a very large table can be a big problem on SaaS. So what we recommend is to create a retention policy starting from the beginning. And this means that
in the implementation phase.
Exactly, in the implementation phase. So you should enable retention policy at the beginning. And then, so decide what are the tables that for you can grow, and apply immediately the retention policies on this table. And to do that is very easy. You should remember that remember that retention policies is something that in Business Central is something like this. Retention policy is something like this. So you need to select the table. But if you select the table, these are not all the tables that you have in Business Central. These are only tables that you, Microsoft or you, have declared as supporting retention policy. So if you want to support, like in my example, the previously showed big table, this table. If you want to support that, you need to add in your extension code the lines of code that you can see in the slide. So in your install, usually in your install per company of this trigger, add this table to retention policy. Otherwise, you cannot see that. And
just the practical tip is when you do this, monitor. Take it with telemetry. Telemetry gives you already a signal that it is the DSH, exactly. And with this one, you know, when it runs, if it runs, how much things have been deleted, and from the standard, and of course from the ones that you have added in order to understand how this one it is evolving. And this is something that happened to me in July 2023. Open up table information. There was 37 million of records and then 10 gig over a database of 40 gigabyte. That was 1/4. And I think, how many of you have had the changelog entry that go in mad? Raise your hand. See you, brother and sister, of course. And this kind of things happen. When it is like that, you cannot enable data retention, because this one, it is canceling 10,000 per 10,000, and it is doing just a mad calculation. Or now this one has to be deleted, which other records to be deleted. So you have to do by your own, by handy. Just creating another job queue that with this entry number, it is deleting little by little. It took 1 week to just silently erase all of this table because it was practically not used. And so the mantra is don't do this once again, keep this monitored and understand how many records are inside. Again, use a retention policy and keep them monitored, and the tip it is calculate your growth rate. There are different ways to calculate. You can go into the capacity of your, from the tenant admin center, or using the admin API in order this to be sent together with telemetry, or somewhere else, and then keep monitored. This month it is 1 gigabyte, the next month it is 2, the other month it is 3, so your average growth per month, it is 1 gigabyte. Then you have to refine per table how much this one it is growing up, right? And remember, Dracaris, avoid the change log and keep this monitoring as much as possible. Otherwise, this blown up the dimension of your databases.
Exactly.
And sooner than later, you cannot create any more sandboxes because of you have grown up too much.
The other big problem when talking about storage, first the data and then the blobs. Blobs should never be stored inside the database. At least is what we absolutely blocks on every our large customer. And sometimes this seems difficult, but it's very easy to provide to the end user the same experience that you have in the attachment, but doing in a particular trick that permits you to automatically save the attachment not inside the Business Central database, but, for example, in blob storage. That costs quite nothing, and you save space in the tenant. And these are the only line of code needed. So you only need, you will have the slides for that. You only need to subscribe to an event in the document attachment table and redirect the attachment of the blob to the blob storage. What happens to the end user? What you can see here. So for the end user, is totally transparent. That this attachment is not saved into Business Central, but is saved into blob storage by using simply these lines of code. For the user, it's totally transparent, but you save space. So your user can also upload 1 terabyte of PDFs or other stuffs, and these are not saved into your Business Central database.
Yes, that's a bad habit example. If you want to see it, this one it is a live example. You might think that this one it is going out. It is going really out of storage, and you know why? Because of they are storing this kind of PDF files inside the database. It is a bad habit. Bad habit that you inherit most probably from the NAV. And the second one it is they have interfaces. These interfaces are going through JSON. And then these JSONs, I don't know why they save it. They save it because maybe they just want to control. They never controlled anything. And you ended up in having 38 gigabyte plus 28 gigabyte in every of these symbol databases copied over and over again. So that we have, of course, added the practice of sending a dragon to who has implemented this one. And don't do this.
Okay, let's start talking about, now we move a step back, a step over, and we go to IL best practice. So what we have done, first of all, the mantra is that you need to write fast and less locking code. And usually if you analyze what happens when you, the Business Central NST runs IL code, you discover that the IL code, so single IL instructions that are not non-database statements, are totally insignificant because one runs in the order of nanoseconds. While what takes time is when your code needs to access the backend. So the NST usually spends a lot of time waiting for database operations because these are where you need to be fast. And so the mantra is that writing a fast and less locking code is crucial in large cars, especially when you have high concurrency.
Perfect. So there have been a lot of tips during BC TechDays and a lot of other documentation that you can find about tips and tricks. We just give you 3. The first one, it is embrace new L object and statement. What it is new, and it is related, of course, on performance, then embrace it. So the things that I did, actually, I just took the base application, and then I've just analyzed how many get. This one, it is not interesting to me. The one that you see in the bottom are interesting. In version 23, there have been this number with settled fees, read isolation, set autocal fees, the read-only that is using the replica query object, and those are the lock table. Lock table, Dracaris. So you have to cut one finger if you want to use a lock table, or you want to develop and add the lock table, okay? Most probably you will end up from this room without one end. I'm pretty sure, many of you. So the things that I did, I analyzed how this one it is evolving. So Microsoft pray what it preach or not. So in version 26, the things that you might see, of course, it is growing, the base application. You might have much more of the statement. But keep this as, this one, it has been increased from 300 to almost 900 settled fields. Do it. Read isolation has been increased as well, set autocal field, read only. And maybe because of copying and pasting all the stuff, it has been also increased at the lock table. But you as a developer, most probably, and even me, when I have it, I completely forget about using lock table. That is one thing. So embrace this new AL and master them at best in your development. Exactly. And the second one, all new objects, plus this should be a pattern that always has to apply. Filters, and with indexes, of course, otherwise it doesn't make any sense. As a covering index for your filters, for your where, then use settled fields, set autocal fields if you have flow fields, and read isolation in order to understand and in order to prevent unwanted locking in, I don't know, calciums is empty, or whenever it is not needed.
Okay, so this is worst, this is good.
Yeah, exactly. As you can see, this one, it is far better than how it was in the past, and if you're still in CAL, move to AL, that we have good practices like the one that it is shown in here.
Yes, the other, so first is this, the slide before is a mantra. The second mantra is that you should avoid loopy loops when you have extremely large tables. And how you can do that, this is a traditional scenario. So imagine that you have to loop in an item table with millions of records, and then for each item, you need to calculate things in the item ledger entry. Doing that in IL language is absolutely time consuming, especially also if you use read relation, something like that, when you have a very, very large table. So it's much better to, in this case, do a bit of work more, but start using, for example, query objects, because query objects works directly at the database level with joins and something like that. And here is where you will see real gains. Just a very quick demo to show that in action. But if I'm going to this table, and here I have a loop that for each of record in this table goes into the my heavy table, so the table with 3 million of record, and does the calculation of the amount. This is, if I run this loop in IL language, so in the traditional loop like in the slides, for calculating the amount, this is, it takes a bit of time. I don't remember how many seconds, but exactly. It loops for each record in this table, it retrieves all the attached ledger entries and calculates the amount. So 12 seconds to do that. I have refactored this loop simply by using a query object. So here I have my query object, this, that does exactly the same. So starts from this table, and from this table goes into the ledger entry table and sums the quantity. Very easy. I'm using this in my procedure. I don't remember where is the procedure. This, okay. Here I'm simply using the query now. So not the loopy loops like in this example. Here was the code in the past. For each I loop the ledger entry table. The code now. Simply calling the query, looping the query. And the difference is that if I run the calculation with the query, the calculation with the query is 1 second compared to about 13 seconds before. So it's absolutely faster, less locking, and so on. So this is other stuff that we have completely refactored on our large customers.
It's super good if you have to aggregate.
Exactly.
Yeah.
Now we start with the last part. We are quite right around out of time, so let's start.
Perfect. Complex integration, that is one of the last in the menu. So complex integration typically goes with API, because everything that you have outside the world it needs to talk with Business Central, and it is exposed in the online version through the APIs. So there are some limitations in the online version that are, those are the rules of the games that you have to obey. So in order to be silent, swift, and deadly using the API, you just have, if you can, use the read-only replica, avoid massive write operation, and of course, use the batch calls. So in order to use the read-only replica, you can specify this. There are 3 ways, basically. where you can specify this. The first one you can specify in the object, in API query, or in the API pages, or even in reports. Of course, those one should not have any kind of write operations, read, update, insert, or delete. Or you can specify this one in the headers when you're doing the call in your get. Of course, the data access intent does not guarantee that you have a read-only. If you're on-prem, you know if you have a read-only replica. In the online, you don't know it because it depends on how you have been scaled up. If your environment, your database of your environment has been scaled up from general purposes to business critical comes up with an additional read-only replica where you can offload all your read of this kind of object. So just to insist in this, remember one of the practice, we have resolved one problem related to queries that are quite frequent and are all just reading, for example, the stock. The read-only replica, it is just a matter of seconds that it is that keeps the data online, and this one it applies on API page, API query, and report. Another way to do it is just through configuration. So if you go into database access intent list, this is something that nobody has seen it doing. So every time I'm just doing this, there is also these other pages, do it.
Yes, it's also
Take it. And with telemetry, there is a specific signal that tells you which are the mostly used report, and it is just very, very easy to do it. You can know which are the mostly used report, you sort it by count, and then take the first 30, and then put them data access intent on. I did it, honestly, and then someone coming back stating, I have an error, then you go back in here, and you put that back, read, write, and then this guy is working on. But the other 29, right now, are going offloaded into the read-only replica, if you know that you have a read-only replica, of course.
Exactly. Then we started, starting from that, we started analyzing the integration that we have with this type of customers. And as you can see, you have seen at the beginning of this session when we show you a real live customer, one of the customers that we mentioned in this demo, you see that these customers are affected also not only by not well-written IL code, but also by a complex integration that they have, so B2B systems or something like that sends to the tenant a very large number of API calls. And these API calls affect the performance of the tenant. So we work in two main aspects on that in the API integration. The first is that we try to minimize the number of API calls that arrives to the tenant. And the first way to optimize that, we start using batches. Batches means that it's an endpoint that APIs have where you can send to the tenant APIs in batches. Just to show you very quickly, because I want to show later a most probably interesting thing than batches. Batches is something that you should use when you want to post transactions. How you can do that? Simply, let me show you granting a token, selecting a tenant, then we go to the batches. So, okay, here is, for example, an example. So, let me load some things, okay. Okay, so here what I need to do, here I want to post I'm an external system, and I want to post a set of transactions to my Business Central environment, in this case, journal lines. By using, you can obviously post one journal lines for record, so this means 1 million of journal lines, 1 million of calls, and this is what we want to avoid. Or you can directly call the batch API. So the batch API means that you need to call this endpoint, api.businesscentral.dynamics.com /API/v2/batch. And you can pass an array or requests, and each request is identified, but what this request can be, in this case is a post request, the URL that I want, where I want to post the record, in my case my journal line. Every request can be identified by an ID, number or something like that. If I post this, what happens is that request is sent to my Business Central. I'm not previously loaded, so probably the first takes time. So these 3 records or 2 records, I don't remember, are automatically posted. And here I have, as a response, So I'm the caller. As a response, I have the status of each call. So I pass 1 million of record, and I know that for this 1 million of record, this is okay, this is not. Sometimes we have also optimized that, because you can also do more complex things when you use batches. For example, you can use isolation by passing the call this, and this means that your batch will be treated as an isolated transactions. So, or always is success or not. And you can specify this header, sometimes is forgotten. What you prefer, what that happens when you post a batch. You want to continue if there's an error or not. Usually, yes, probably, when you want to translate, post to a set of, for example, warehouse entry. If I want to receive an error only for the transaction that is wrong, but all the others can be successfully registered. And you can also optimize the output. So in my case, in this case, is what I prefer to do, is the caller can also pass this in each request. So prefer return no content means that if I run this, now the output is simply this. So I don't have the biggest JSON in output, but I simply have for each element if it's okay or not. Not the entire JSON that for me as a caller is totally unuseful. Because I don't want to know the entire JSON that is the same JSON that I pass. So it's optimize the transaction. And just go back again to the slides for the last part. When we analyze, as Duilio at the beginning I showed the customer. And when we analyze this customer, this was the situation. So a lot of API calls during each time of the day with a very, very large number of API calls. Very.
Show the very.
This was also.
This is another one. So he said, I have a very. Oh, you don't have a situation like this. This was spiking more than 1,000 calls. We never received too many calls, honestly, but it was really hard, and it was giving just hammering the NST behind the scene. But then we have optimized it. Not in the way that will show Stefano. We have asked the third party in order to introduce a basketing system in order to send batch calls instead of completely hammering the. And this is how it is right now.
And so we decided to optimize this behavior because too much calls are sent to the tenant. So something should be done. And how to optimize that? We have. You should also remember. That there's also not only Business Central, there's also something outside of the Business Central box that sometimes can be helpful to you. And this is exactly what we have done. So we are, first of all, start analyzing the queries, the API queries that comes to that tenant. And we discovered that the most part of that was GET operations because a B2B, different B2Bs need to call how is the price for this item, how is the inventory for this item, how is the availability. So a lot of GETs. And we decided to optimize GETs. How? Using a middle layer between APIs and Business Central with caching. This permits to what happens in very quickly show to do that. It's very easy to implement these scenarios. This scenario is simply creating a wrapper between Business Central and your external system. This wrapper is let me close something. This wrapper is a simple Azure function. A simple Azure function that works connected with a cache. What cache? The cache is in Azure. There's a nice service called Azure Redis cache that you can use. So the trick here is the external API calls are sent not to api.businesscentral.dynamics.com, but are sent to an endpoint that is my Azure function that simply acts as a router. You are an external system. You are calling me for the availability of this item or for the address of this customer. Do I have this data in cache? If yes, I return this data immediately without going to Business Central. If not, then it forwards to Business Central, calls the Business Central API, gives the customer, saves the data on cache, and then so on. So it's very easy to implement that. with a few lines of code, like in this example. So here I have simply an HTTP get Azure function that simply receives the get operations, retrieves the bearer token, okay, and simply what is doing here is retrieving the filter or not that you have passed, and checks if the data is in cache. Data is in cache. If yes, is returning data in cache, like this. Otherwise, if data is not in cache, it sets the value in the cache with a delay when I consider the data valid or not. In this case, 5 minutes. I consider the data valid for 5 minutes. If this period is expired, data is the cache expires, and then I return the records. What happens here is, I hope to be able to show that. Here is, if I calling, for example, I want to retrieve the data for a customer. If I call the standard APIs takes about this time. If I call this endpoint now takes quite the same time, but because the data was not in cache. But now the data is in cache. If I recall this, you can see that now the time is very limited. And this second call, third call that I can run. Impressive. So all the other calls are immediately executed, and they are not redirected to Business Central. So Business Central is offloaded. I can continue to do that, send them 1 million of calls immediately, and they respond. Why, if this was all redirected to Business Central, you have timeouts or too many requests and something like that. And this saves a lot. So we change, this was our situation. So after that trick, we moved from this to this. So all the get operation was absolutely reduced. Obviously, so this is a chart that shows you the response time also. We also gain in response time for many of the massive operations that we have in these customers. And also, obviously, the problem is what is the post. The post is something that you cannot cache. So if you want to post something. For the post, we have simply, in some scenarios, use the same trick. So we have used the Azure function as a middle layer. We enqueue in Azure Queue or Azure Service Bus, it depends. We enqueue the post in request, and then from Business Central, as Duilio showed at the beginning, the trick is serialized. So is Business Central then takes and queue the queue and handle the post. So this can be useful if you want to also detach the massive posting to the Business Central service. This helps on saving times and logs. So these are tricks that we have applied to our customers. I hope that some of these you can apply to yours. If you have questions now, we have a slot for questions. We have also here some T-shirts if you want to.
And ducks.
And ducks also. We want to share everything. So feel free to do the question. That's the first question. Thanks a lot. Dagli la maglietta.
Question? T-shirt?
Microphone.
Dracaris.
Okay. Do you prefer to using Azure Functions for these things or Azure App Service web app?
Sorry, can you repeat the question?
What's your preference regarding using Azure Functions instead of Azure App Service web app?
We have used an Azure function in this example was an Azure function in the Flex model. Flex model is a new Azure function deployment model that has the advantages to be extremely scalable, and also the advantage to don't have cold start. So it immediately reacts. It's absolutely much more performant than using a standard API exposed on app services. Much faster. So for us, it was a winning choice.
Okay.
Good. Hup. T-shirt or duck?
Okay,
duck.
Okay.
A T-shirt. T-shirt.
The data you have in cache, when you call the Azure function, thank you. So is not making that is not real time. So it's not the same thing that if we ask the external system to reduce the frequency of the API calls. So I think if the frequency is high, it's only to have the data in real time, right?
The thing is that you have to define for every single entity how much it is defined for you, it is good for you to stay in the cache.
Exactly. The trick of the cache is useful, obviously, when for you is okay to maintain the data. So, for example, if I have an external system that needs to check for the address of the customer, of the shipment address of the customer, probably real time is not needed because or in your business you can define that for me the data, like in my example, the data is valid for 5 minutes. For 5 minutes, also if someone in the minutes number 3 changes the address of the customer, the data valid is what I have in the cache. Okay. This is an assumption that you need to check, obviously, in your...
But so in your scenarios when you have multiple interfaces, that's called the customer API, right? Because if there are only one, I ask to the interface to reduce the timing of the calls, right?
Exactly,
okay,
yes.
Okay, thank you.
The Azure function is one that simply routes retrieves the call. Instead of calling API.businesscenter.dynamics, we takes the URL and redirects to the APIs.
Duck. Shirt.
Oops. Mamma mia.
There are lights.
No problem. Just I have a small question about retention policy strategy.
Yeah.
For example, if you have a log table used to track process operations, and this table belongs to another extensions and not to my own extensions, is there a way to apply retention policy for such table?
You can define, yes, you can define the retention policy for this table, like you do also
but it's
for the base application, also for the other ones.
Yeah, it doesn't belong to my own extension.
Yes, but you can apply retention policies.
For sure.
You need to add in code.
That you.
I remember I have tried, but you cannot.
The third part. Then how you do it with the base application? Base application for you.
It is a your extension need to depend from the others, obviously. Otherwise, you don't see the.
You have to declare the dependency.
And then in code, you can register the.
And you can do whatever you like.
Okay.
Yes.
Plus the permissions.
Yes, and the permissions.
Otherwise, it gives you an error. Your license does not contain blah, 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 blah.
Sounds good. Thank you.
Not working?
It checks the current module information when you call this method. You have to be the module that adds this table to register it with the system app procedure. Only the owner of this table, the app can add it. Then you have to talk to the other publisher, or if it's a base app, use the base app contribution pilot and do it yourself. Yes, I've already did for about 10 tables.
Honestly, never had this kind of problem with the one that I have to put into retention policy. Always owned by us. Otherwise, you have to ask, as mentioned, Microsoft in order to allow to be added into retention policy, or the third party in order to create retention policies.